Hello and welcome to part 1 of the story of Witness Me. Witness Me is my 12-pound hobby weight one-wheel Melty Brain robot. It is my first time building a hobby weight robot, and it is a scaled up version of my Beetle weight Kansai Drifto. Kansai Drifto has had a long story at this point. I haven't told it yet, but one day I'll get around to making some videos on it. I didn't have too much time to work to design Witness Me, so the main strategy of it was to just take the things that worked in the 3-pounder and then scale them up literally 4 times into the 12-pound. So in situations where Kansai Drifto has 1 motor, Witness Me will have 4 motors. The speed controllers used are the same in both of them. The logic is the same. It just had to have like a little bit of bootstrapping to signal all of the electronics so that they don't strain out the Arduino that runs it. Before we get into the details though, I should explain why it's called Witness Me. Witness Me is a reference to Mad Max. It keeps the theming of cars that Kansai Drifto has, while also referring to the excessive engine power that both Mad Max and this robot portray. In line with the warboys yelling "Witness Me" before doing a courageous, dangerous, and often explosively sacrificial act, this robot will exhibit similar traits with a highly dangerous weapon and low likely chance of survival. Before we get into the design of Witness Me, I'm going to explain just quickly how a Melty Brain works for those who aren't aware. So this is my 3-pounder here, but the idea is the same. One-wheel and 2-wheel Melty Brains have the same logic applied to it, it's just how they actually rotate slightly different. So the idea is that the wheel here will spin the entire robot, and with a 1-wheel Melty, it very quickly lifts up off the ground and spins about its center of mass. So the idea is, as it's going around, you will pulse the wheels on and off at given moments. So like pulse on for like half a rotation, pulse off for the other half. You can do alternatives to this, like you could brake instead or have like a smaller pulse to give you different varying effects. But the idea is that doing so will cause it to traverse overall along a line of travel. This is called translational drift and how they all move around. To understand where the robot is actually traveling, they often have a heading light. So in this case, it would be right here. So the idea is that this light will blink on for a period of time that will create an arc of light that you can see due to persistence of vision. You'll be able to see it as a human quite easily. So it'll basically make like an arc that'll look like it shines about, however large you want the circle to be. In my case, I make it, I think, 1/6 of an arc. And the idea is that gives the pilot feedback of where forward is, and then you can map movement based off of that. There are many ways to figure out the path of where it goes. The most common and what is used in my current ones is accelerometers, but they can also be used through wheel encoders, timings, light beacons, and other various things like that. And the advantage then of a Melty is the fact that when you hit the robot, you're actually hitting them with the entire weight of the robot behind it. Now, granted, these normally end up having the robots both ricochet in opposite directions. Horizontal weaponed robots in general have this problem, but it seems to be even worse with the Melty just because they often don't have as much traction at that particular moment. Because it's very easy, especially with a 1-wheel Melty, to just have it pop off the ground and go. That's the basics of how these things work, and now we'll jump into the design of Witness Me. Time to talk about the design of Witness Me. And first we'll do that by looking at the 3-pound version. So the idea for Witness Me was to take this 3-pound version and just scale everything up by 4. The reason was to reduce parts that need completely new R&D, which should shrink development time, and also have the bonus that some feedback could be used back in the 3-pounder. There were some parts that need to stay the same, but looking at this will show the general layout of how things were going to be planned. My 3-pound works by having 2 3S batteries linked in series to make 6S. It also has a 2S battery for the logic to run the microcontroller, and the drive is opto-isolated between it. It contains an accelerometer to gauge the amount of rotation the bot's going under, and we have the speed controller just right here to run the motor. So with this, one of the main concerns was going to be how to run the motor system to do it up. So what I worked on next was to figure out the exact designs I wanted to go through the motor. So I started prototyping some ideas, design prototyping. So the first one here was to run 4 motors together and run like pinion gears and then a hub gear. We'd connect to some kind of hub, and that would attach to the wheel. These were meant to be needle roller bearings, and then we'd have a thrust bearing right here. And so yeah, the idea is they'd all work together, spin it up, and everything would go from there. And to hold it all together would be a shoulder bolt that's tucked in here, and I'd pull it out. And this is basically the smallest the assembly could get, just because if you look at the spacing, that's basically as tight as they could get with enough safety clearance that they're not touching each other. I then decided to prototype a second idea just for the sake of experimentation. What would it be like if it was pulleys? And basically it just comes out like this. It's pretty similar in the idea, I went through this just because in general I seem to like running things through belts. They have that little bit of forgiveness in them. If this were to actually be done as a design, these belts would need to have tensioners on here just to make it so that removing this pulley and wheel assembly would be easier. So I went into a third design. So one of the things I needed to try and work on was to get off-the-shelf parts. I wanted to use mod 1.5 gears, but that doesn't work well with a 5mm like shaft that these motors run on. They all want to start at the minimum of 6mm shafts. So I decided to look into mod 1, or sorry, at this point I'm still trying to do mod 1.5. The idea was going to be, I grab these Servo Cities hubs here, and then I would get these laser cut out of like a series of 1/16 sheets, and then bolt them into the hubs here, connect them in, and then still once again have this hub gear, have the bolts go through the collection here. This would also be 1/16 sheets of steel. So the bolts will go through here, go through the hub and into the wheel. We have underneath the hub the 2 needle bearings still. And then we would have a thrust bearing right here, as well as a spacer, and then some mounts to hold this all together. I then worked on the idea of having the kind of figure that this would contain to hold it within the chassis if it were to sit inside one. And I had this backing piece here with the idea of trying to support the motors more. And then I jump over to what I ended up going with here. The idea here is that I found a bunch of Traxxas parts that were very cheap to like fit into here, so I tried working with them. So moving the wheel, we can see here, the idea is that there's just simple pinions, and then this was like an off-the-shelf gear. I went with this kind of a solution because I could actually try a couple gear ratios without having to order new plates each time, just because the math would work out, like running a bigger hub gear and then smaller pinions would all work together. I kept a bunch of this other stuff here. The reason that there's a spacer in here is so that if I need to, I can just pull the bolt out here and take these pieces out and then slide the wheel off. The idea being that I'm going to go through a wheel at basically every single match, so it's ideal that it can be replaced easily. For the first iteration, I also still had support at the back here done the same way with plastic, but then I iterated it further, unfortunately after ordering some of the parts, to have this extra support here to hold the motor nicely. So instead of running 2 3S batteries in series, these run 2 6S batteries, I guess as independent circuits. So the idea is I have 2 speed controllers here now that are each going to run 2 motors, and so these circuit banks are completely isolated. So this battery only runs these 2 motors, and this battery only runs these 2 motors. The speed controllers are communicated through opto-isolation again. The only thing I had to do really differently was to bootstrap the signal through a separate MOSFET on the circuit board here, and that basically just meant that I'm not running current through opto-isolators to power them. It was just to put less stress on the microcontroller. The accelerometer stayed the same, and as such I'll have 3 power switches, like one down here, one over here, and then this one will power the logic. The logic batteries are exactly the same, they're just tucked away in here. The batteries are held in with TPU 3D print and the support pillars here. I run these support pillars all around here to hold the battery in place. I ran power indication lights all over, so these are for each of the circuits for the batteries. And then I use the signal lights here for the Melty Brain to show indication for the microcontroller power as it's needed. For the LED brackets though, I also had a second idea planned. Basically I found some super bright 10mm LEDs, and I built a second bracket here, which was just going to slot into this area right here. And so otherwise, yes, this was basically just a scaled up version of it. I had some holes placed in here to have a little spacer put in, with the idea that this wheel would be prevented from going forward and bumping into like all of this assembly in here, but I instead modified the chassis to work as the stop right here. For the chassis, I used CNC Madness. It was my first time using them. The parts came out quite well, so no problem with that. And then everything, all of the metal parts were send cut send. So yeah, with that we can jump into the finer details of each of these pieces. Between the prototype designs and the final CAD you just saw, I worked on the electronics. This was done for 2 reasons. 1, I wanted the size of the PCBs known for designing the CAD, and 2, I get my PCBs made through Oshpark, which is a great price for 2-ounce thickness PCBs, but the free shipping option is slow, so I want to give them as much time as possible to get to me. I already knew the optocoupler I wanted to use, as well as the MOSFET to signal it. What I needed to confirm is if it could handle the load, as well as how much the timing would be affected, as I'm running it on twice the load now. I was pretty sure this would work, as everything looks to still be within the specs on the datasheet, but I had the parts already and could easily confirm, so I did so. Those tests came out well, and I was even able to confirm the performance matched the specifications within the datasheet, which was nice. After that was on to stress test the MOSFETs by powering on the LEDs. I figured a 5-minute full-duty stress test should be enough, as the light will only be running about 1/6 duty cycle during a fight, and 5 minutes should be plenty of time between powering on the robot and getting the fight started. It all came out clear, so the next step was to design the actual PCBs. With the components all vetted out now, it was time to actually design the PCBs to have them made. So for my microcontroller schematic, I broke it down into a few discrete sections. First here we have is just basically the LEDs for signaling. The idea is that the voltage comes in from the battery, a 2S battery, goes directly into the microcontroller, and also goes off into this LED bank. So basically we have 4 current limiting resistors that go off into 4 pairs of 2 blue LEDs. So the resistor plus the voltage drop through the LEDs comes out, it comes back in, and comes into this switching MOSFET that's right here. So what happens here is the microcontroller can signal to the MOSFET, and that pulls the whole connection to ground, completing the circuit, and the lights can blink. Similar to the LEDs, the drive and brake MOSFETs also pull to ground to complete the circuit, with 1 of each. And then we also have a logic level converter here. The accelerometer I use is 3.3 volts strict, whereas the microcontroller is 5 volts, so I have to actually have a logic level converter in here. And just for a fun fact for people who are new to doing this kind of stuff and looking to learn a little more, the reason I have this logic level converter built up right here is what happened is I originally used a SparkFun logic level converter. And what happened is it worked well. This is a bidirectional one, which is exactly what I need for this kind of thing. And the nice thing about it is you can click on documentation and you can go to the schematic. And you pull up the schematic here and they just tell you what it is. So basically the logic level converter was 4 discrete sections. They basically convert your low and high level voltage. The component is mentioned right here. It's a BSS138. And then to order the components, if you ever were worried, you can just go to a place like DigiKey. So you search for it, you get BSS138. This is a MOSFET here. You click on it, it'll give you all of the instructions you need. And also you can buy like a 10-pack for $1 Canadian. And yeah, that's just how you go about getting them. So I originally got this FET and used it in my projects for the logic level converter to pull off needing to use a breakout board to save a bit of space. And as a result, I checked the MOSFETs out and they can handle a good enough amount of current that they are useful for everything. So I just picked this as a general component I like to use for working on all of the things I need to signal. So that handles all of the microcontroller side of things. Then the other side is the speed controller. So there's going to be 2 of these in the robot. So the idea is that this also gets 2S voltage coming in on here, gets a current limiting resistor, and that goes off to each of the optocouplers. So for people who aren't aware, an optocoupler is sort of like a switch that is isolating the 2 sides. So the idea is what actually happens is when I signal this, it signals a little LED in here that goes off to a phototransistor here, which allows the circuits to complete. So within here I have 2 optocouplers. One is for powering the drive side and the other side is for powering the brake side. So yeah, basically the voltage comes in. When signaled by this, it completes all of the circuits here to drive the motors. And then same thing with the braking on this side. And as a bonus, I have the little indication LED to tell when I've powered this circuit. And yeah, so this will power 2 motors for one side of the robot, and then, like I say, I have 2 to power all 4 motors altogether. So then after you get the schematics done, it's on to drawing the PCBs. This one came out pretty clean, as we can see here. So this is the microcontroller here. We have the logic level converter on this side, and then we have the LEDs, drive, brake, and then the return for the LEDs. So this is power out to the LEDs and then power back in. There's only one minor improvement that I think I could do on this, which is that I take power in only one spot. If I had 2 breakouts for the power in as well, this is the 2S battery that goes in to power it. I could have more easily powered the speed controller's requirements for it, but as a result I had to split the bus wire, which is just more annoying soldering, but minor issue. So the speed controller was a lot more complicated to get done. I was hoping to only have 1 spot in for the high voltage and then 1 spot out for the ground, but it made it easier to have 2 grounds and 2 positive ins to lay out all the components. So this just basically has the 2S in from the battery. These go to ground as signaled on the microcontroller. That's what these parts are here. And yeah, so these are the optocouplers here. So the voltage goes in, comes signals for that. And then otherwise, yeah, we have our power indicating LED here. We have the braking MOSFET here and the drive MOSFET here. Same on this side, braking here and drive here. The drive MOSFET is much larger than the braking one, just because the braking is just so much less load in this. That I don't need to worry about that as much. So yeah, with that, I complete these schematics. I send it off to Oshpark. So they're a PCB manufacturer in the US. So they have free shipping and also a free upgrade to a 2-ounce thickness of copper. And that's great for getting these small little boards done. Unfortunately, the postal strike was going on in Canada at the same time. I checked with them first, and they said that they had shipping in place such that the postal strike won't affect it. Unfortunately, my package also got mixed up within the shipping service and wasn't updating. So I contacted Oshpark, and they said, don't worry about it, we'll get more boards made and send them off to you again using faster shipping this time to make up for it. The end result was I ended up getting my boards about 3 weeks before the competition. This was a bit later than I'd planned, but sometimes that stuff happens. So I assembled the PCBs and slapped them into the robot, but I'm getting a bit ahead of myself. We need to talk about the chassis a bit more first. So rewinding a bit to when the PCBs had just been finished designed, so they'd been sent off to Oshpark to be created, and so the next step was to finalize the CAD. So I rendered up the whole CAD, and I found them very close to weight. So to help mitigate this, my strategy is to order all of the parts except the weapon tooth, then assemble the entire robot, and weigh it and see which weight I have left. If it looks like it's good, order the weapon tooth as it is. If it's not, redesign the weapon tooth and then order that. Since the weapon tooth will be likely coming from Sencut Send, they're reliably about 2 weeks from order to in hand, so that wasn't too much of a concern timing-wise. I did hit one bump along the way. The standoffs I used to hold together these battery packs, I ordered what was supposed to be 8mm width on them, but they ended up being 7mm. It was just a minor issue. I had to adjust the CAD, redesign a couple things, but it was just a little hiccup along the way, nothing too big there. Other than that, all the parts came together okay. I started assembling the robot. I got the whole thing together, was able to run a couple power tests as well. And with it at that point, I was able to then order the tooth from Sencut Send and put the rest of the machine together. Alright, I'm going to go over how the wiring is all laid out for this robot. Currently what is left over is that the lighting for the bottom heading light is not attached. This is just to allow me to program the microcontroller and calibrate the headings more easily. So we have the microcontroller right here with its embedded antenna. It's an NRF24L01. Over here we have the accelerometer, which is used to grab the heading. The Arduino is a 16 megahertz, 5 volt, 8-bit microcontroller. The accelerometer is a 3.3 volt accelerometer, so I have logic level converters right here to allow it to communicate to the microcontroller. On this side here, I have the wiring for the LEDs. The LED light wires come out, go into here, and then pull down. And we have a set of pull down MOSFETs right here. Basically, they'll complete the connection to ground. So we have the LED settings, and then we have the brakes in yellow and the throttle in the blue wiring. And those, so basically what happens is the microcontroller signals the given FET for the action, and it'll do what it needs to. So these branch out over to here. The speed controllers are here and here. They are the same speed controller, and they're to match to the 4 motors over here. So the idea is that these are each the same. They are opto-isolated, so we have the signals go in and connect to an opto-isolator. Let's see if I can get that. There we go. So we have opto-isolators here and here. So that controls basically the drive and brake of this. And yeah, so what happens is the signals come into here, and they'll either signal, the microcontroller controls it such that we'll never use the drive and brake at the same time. Otherwise, they'll create a short circuit, they'll blow. These are half bridges set up. So we have a half bridge here, another half bridge here, but they're each controlled by the same optocouplers. So one signal here connects off to 2 optocouplers, and then they're synced to 2 sets of FETs each. So the idea is that one signal sends off and divides basically into 2, which then divides into 2 again to control the 4 motors in sync. So yeah, over here we basically have our NFET, our PFET. So basically this is used to control the braking. It's smaller just because there's a lot less heat generated in braking than there is in the drive. And then yeah, this is the drive ESC here. It's built for 120 amps, and that is more than these motors draw, but that is just so that I don't need to put any kind of cooling on here. The speed controllers also have a little signal light right here, just to let me know when they're turned on. So the wiring goes such that there is going to be 2 1S batteries that come out here. They're going to connect into here and power the microcontroller, as well as like the optocouplers and stuff will be powered off of it. And then each bank, so like we have the left bank, or this is the robots, right? But anyways, one bank and the other bank over here they are going to be powered by their each independent batteries. So there will be 6S 2.2 amp hour batteries in here. So they'll plug into here, go down to each of their own switches. When they're powered on, like say the LEDs that are here and here will turn on to let me know I've powered each circuit, so I don't accidentally only turn on one of the power systems. Then yeah, so that'll route all the connections to this. This opto-isolates the logic from the hardware, just because this is drawing so much more current that like the noise will be too much for the microcontroller. I've had that problem in the Beatles before when dealing with these multi-brain styles. So yeah, that's the basic layout of it. Hopefully everything works. I haven't turned anything on yet. That'll hopefully be tonight. And yeah, the idea being that we'll see if anything, or if everything works as I expected, or if things go wrong. We are about 2 weeks away from competition, so if anything goes wrong, I will not be able to get new PCBs made in time with any kind of fixes. I do have spare PCBs if it's the case of I blow one and I need to just make more. That's not a big deal. I plan on making spares anyway. And if I need to just patch a little wire to fix it, I can hopefully do that. So yeah, that's the whole layout here. What this will drive then is 4 motors here. And so they'll all spin the same rotation, which will cause a hub gear here, which will be interfacing here to spin and then run the wheel, which will be right here. And yeah, hopefully this works out okay. So I'm about to do the first test power up in here. I've got the batteries for the microcontroller lightly installed in here. So I'm going to try and power it on, and these LEDs should be blinking if I do this correctly. Just because I'll just be powering on the main board here. Yeah, right here. Yep, they are blinking to show that they do not have signal. So I'm going to turn on my controller now. They are solid. Good. So throttle is set to nothing. We're going to turn on one power bank and try to run it. All right, I see the green power light on the one power bank. Why doesn't it seem to be getting hot? It worked. Excellent. Let's turn on the second power bank. There it goes. Ugh, that twisted this a little bit. That'll hopefully not be an issue later, but yeah, I can see the lights from underneath. That's good. It's the green LEDs. You can see it on the camera just a little bit right there, and then there's a corresponding over there. So if I do this a little bit. Good. Nothing's gotten hot. Everything works correctly. That sounds wild, and that's only at 50% throttle. Let's add some braking in there. So yeah, I'm just throttling the brake a tiny bit. That sounds so fucking crazy. Now it's time to discuss the details of the hub design and then on to testing. So I'd like to talk about my hub design. I went here to bind this gear to the wheel for the drive system. So after a few iterations, I decided to try and go with off-the-shelf Mod 1 gears. It just seemed like a cost-effective, easy thing to go for, although ideally I wanted a gear with a mod higher than this. Like, the reason I wanted a higher mod was just so that I'd have a little bit more clearance to play with. If this ends up not working, then I will end up considering getting 3D metal printed gears, because that might be the most cost-effective way to get it, mainly because the shafts on the motors are 5 mils and mod, like 1.5 mod gears, do not come with the 5 mil bore on them. At least not anything I can find. Anyways, this is a off-the-shelf Traxxas gear. This is just ordered off AliExpress. It was about $10. So what I had to do is create a hub design so that it would fit onto the wheel. So I need to figure out how to mate this to basically an intermediate piece. So I ended up first having to be like, I have no measurements or anything on here. So I used calipers and figured out roughly what I thought it would be. You know, this was obviously going to be metric. And so I had my first prototype I printed, which was this, just to see if it worked. And this did in fact line up correctly. I guess the number's right on. So then what I wanted to do was I'd like this has spots for 3 screws to go in there, but they're M3s. I figured that wouldn't be enough, so I was going to add a couple extra screws here, in these other gaps here, a total of 9 M3 screws. And I figured that should be enough. So what I ended up doing was, I didn't know what the spacing was going to be on these parts here. So I first off started by guessing it was all going to be equal spacing. But when I lined it up, the holes were just slightly off. So I went with a second iteration where I just tried moving the spacing a little bit on here. I had a little key on here to show where it lines up with one of the main 3 holes. And then these ones, I brought them a little closer, and that was basically on the spot. So I think it was like a tiny bit off, and I adjusted for this third iteration. And then for the third iteration, I printed little bumps in here to help kind of key to the body, but like so. And that worked okay. So I printed the proper thickness that it was going to be for the threads to engage with, and also the full thickness of this to see if it'd be the right height, and it was, and the screws connected okay, so that was good. But then I hit a bit of a snag. So I had allocated about 4 mils of material here, but I realized I also wanted to separately have a ring, like a little bit of a smaller diameter here to catch the bearings, which I'll mention in a moment, so they didn't have any chance of sliding out the back end. So I was going to do that by having the hub be 2 pieces, be 1 piece be a thin layer of this, and then the other piece be the rest that engages to, but that'd only leave a couple mils for the threads to gauge in, as opposed to like say 4, which should be enough. So instead of running it like that, I ended up dropping these ends and coming up with just a flat surface on the end that this is just going to lay against and bolt into. So then with the rest of the design, like I say, I have a little bit smaller diameter here to match the bearings. These are just some needle bearings. They press into here. They're more closely an interference fit, but it's close enough for what this is. And then I have this pattern in here, which matches up to a Bainbots wheel. This is basically copied and pasted off of Homer. Homer uses imperial, but this is switched to metric because I tried to make as much of this robot in metric as possible. And they just keys into here, snaps together. And I'm not going to push it in because it actually fits very firmly. And then otherwise I just drill 6 holes in here using a jig, and then they match in like this. And that makes the whole collection together. So I have, like you see, the 9 pieces in here. The holes might be slightly off. I think you can see like one screws out like a bit of an angle, but it's tight enough that it should be fine, considering that this isn't going to push at all. This is just going to rotate the robot. I think it'll be okay, but if I'm not, that's what we'll learn. So that was the main idea with the hub. The general design with the wheel is such that I can, it will, actually here's a bit of the stack up. The idea is going to be, these pieces will be aluminum in the final version. The idea is going to be, I'm going to pull the bolt out, this spacer will just come off, and then I can slide the wheel just a little bit forward and up and out, and then I can easily just swap wheels with already installed hubs and all that stuff without having to take apart a chunk of the robot. My 3-pound Melty Brain robot, which has a very similar general layout, requires basically removing the entire motor in order to do that, and that would obviously become even more cumbersome once we're moving up into like running 4 motors at once to run a wheel. So I tried to create a system where I could easily swap the wheels, and it looks like it's going to work just fine for that. And yeah, so that's my hub design for this. These are just M4s on this, and they're number 6s, I think, on Homer. And yeah, they just screw into here as well. And yeah, I couldn't make this any thicker here because I'd basically done the design too far, that it would require too much patching up to make this a little thicker at that point for running the 3 mil stuff. Or sorry, you know what I was talking about, the having the 4 mil thickness in here, and I couldn't make it really thicker without having to change a bunch of move another bunch of parts around, and I was already trying to like keep the robot as small as I can in that area. So that's created the hub, and yeah, we'll see if it works. Alright, so what I'm doing here is the very first spin test ever for Witness Me. Just a note here, I film at 30 frames per second, and the bot targets a rate of 30 hertz for its spinning, so there'll be some camera oddities in here as a result. It has its training discs on, so if it bumps the walls, it shouldn't tear anything to pieces. Turn on first power. Should show the green lights? Yeah, so we got the green lights, and then the blue on top indicates we have power. Alright, let's see what happens. All right, so functionally works fine. That wheel is not going to last very long though. It is shredding stuff all over the place while it goes. So, notably so, calibration was off on this. That was expected. That's one of the reasons it's being tested right now. Let's look at this wheel more up close. In case the motors feel a tiny bit warm. Oh, yeah. All right, we get a good shot on this. Yeah, boom. So we can see right here, that wheel. Ah, I see. It worked the opposite way. The wheel has bumped forward. I expect it to go backwards because that's where the center mass should be here. So it should be pulling the wheel away. For some reason it isn't. Maybe that's just when it moves. And it is shredding the ever-living crap out of this. So I wonder if I'll be able to fix that in some kind of way. I could even just like funnel this or file that down a little bit. If it's just here too, it's a self-clearing problem, right? But explain why it moves so chunky. Like it took a lot of extra force than it seemed like it should to get going. Interesting. Maybe I'll just have a little spacer in there. At this point, I just toss the bot back in the box for one more run, just to get some calibration data. What I'm calibrating is the center of mass. What happens is it gets calculated and then baked into some lookup tables so that the code could run as fast as possible. With some calibration in place, the heading light is now drifting a lot slower. And I don't believe I immediately noticed that bolt go flying out from inside the robot. Either way, the robot is a lot more controllable now. I can modify where the heading light is relative to the bot using the right joystick, which allows me to compensate for calibration issues and also turn where forward is on the robot. Excellent. And that was only at, I think, around a little bit more than 20% throttle. Let's call it between 20 and 25% throttle. So a couple things I found in my initial testing. One is that when this is spinning, the actual weight of the finger tech switch there and this, it's enough that it pulls actually outwards from its center of rotation, and this whole post rotates a little bit. Now I can crank down the screw a little bit more to do it, but I'm actually going to print my another post like this that just flanges out a bit more, so that when it butts it against the battery, which is in here like this, it'll just have more against the battery so that it resists its rotation, plus I'll, tighten it down a bit more. The other is that the wheel here, you can kind of see, there. You can see the depth difference between here and here. What happened is the idea was supposed to be that this piece of plastic that sticks out on the chassis here is supposed to block this from moving too far inward before the, say, the match begins or whatever. And the idea was supposed to be that when it starts, the force of this spinning causes this to pull backwards because it'll be all shifting away from the center of rotation, and it should keep it in place. But either because I tightened this bolt down too much and it actually compressed this a little bit, or there's something else I didn't quite figure out correctly, this rubbed against it and carved a little bit away. Once it clearanced it was fine, but it made a huge mess, and it's extra resistance, all that kind of stuff. So I have a just a little spacer here that'll keep it in place. That should keep it just about away from touching it. If we were to ever try and do that, it'll be still then plastic on plastic, which will cause its own problem, but hopefully be less bad, but we'll see. And for fun, look at the mess that this thing already made. Fortunately, since these things just pop right off, it's actually gonna be quite easy to clean. But yeah, it sure did chunk a lot of itself, and of course it's all in the test box too. All right, I think I figured out what's going on. The slight bit of play in the wheel, like this, means that when it's pulling off, the wheel is tilting, so it's going a bit from the force of like the robot pulling away, and this having traction on the ground here creates a pivot point around here because the bearings don't sit like super tight on the shoulder bolt there. So that ends up causing it to tilt, and that's causing it to grind into, in theory, the top piece. Now where it feels a little suspect of this theory though is that the plastic is a little damaged in there, which would be counter to the idea of it tilting this way, because it shouldn't be touching the plastic that's there then. It should be touching the plastic that's here. And it definitely did. It left black marks on it. But it doesn't look worn down in any way. So I have the little plastic spacer in there now, which is good. But it might be a case of that I have to actually trim the chassis a little bit here and here. to make sure that doesn't happen. Just to give it a little bit more clearance, and that the idea of not having a little spacer plastic thing was just wrong. So that's unfortunate if the case. It does line up with some of the issues I have with my 3-pound as well, which I have actually have clearance around for it, and it loops like it makes a little almost natural dog bone because it gives it a little clearance right where the extra thickness of the wheel protrudes out so that it can wobble back around. I don't know why I, for some reason, did not think of that for this one. I guess I just thought the system would be more rigid than that, but it's not, and that was likely just my mistake. And yeah, so we'll see. I might have to cut, like I say, this little bit out here and there, and then the corresponding, you know, corners here and here, shorten them down. And it's just too bad that that idea didn't work, because it's a little more annoying to get this little piece of plastic in there, but it's not the worst. Another thing I had found is that the bearing here had actually fallen out of its hub. So this was like basically kind of an interference fit, and the fact that it's already like wobbled out enough from just a little bit that it could just slide out on its own makes me concerned for the hub life. I was hoping that these things would last, that these hubs here would last like the entire tournament. I would have 3 of them, but I might just have to have a bunch of spares as well and swap them out. You know, hopefully maybe a day 1, day 2 kind of thing or something. Good thing to know now. So thankful for having this done enough that I can test it, you know, before the day before. That also was probably why it was wobbling a little bit more in here. That doesn't change any of my other theories, but because I think this will still wobble enough to bump into that, but we'll see when I put it back together again. I really like my idea of using this little segmented section for working on things. Like, it's really easy to take the armor pieces off and just put them back on. Takes like no time at all. Easy to service, easy to replace. So pretty happy with that. So I need to modify the shell, and I find it a bit amusing that I can just lift the entire assembly out and it just kind of stays together through all of the wiring. All right, so this here is going to be a simple test. I'm going to be checking speeds and to check that if I've fixed the problem with the wheel getting eaten up by the frame of the robot. Felt like I was hearing something a little strange there, so I killed it. Yeah, the screw fell out. From what? Is that from the wheel hub? So a little bit of the wheel got chewed up in that case too, but yeah, the actual hub bolts. So there's these, I put 6 of these in here. I might need to try running deeper ones, because yeah, they popped out, the wheel became loose, the wheel bumped into the edge of the chassis, and yeah, that's where all the sadness came. So good thing the test was done. Time to shut this off and take it apart and get into that. I guess also on this, the motors, they got a bit warm doing that, but I mean also it was taking a braking force on there, but they're not hot or anything. Not that that was a very long test, but you know, still good to know. I have replaced the bolts that hold the wheel to the hub. They were 12 millimeter in length before, they're now 16. So that should be just that little bit extra, holding everything together better. The hub has got some wear. The spacer that keeps the wheel from bumping into the side of the chassis had melted a little to the hub itself. I'm going to see if that gets worse. I think it might not. I think it was the result of the wheel coming off, pushed everything a little awkwardly. That's the hope at least, but we're going to give it a go. The wheel's a little wobbly here now. That feels a lot more wobbly than it was, I think. I didn't get any more chunks coming off the wheel, which is good. let's give her a go again. Start it up, just hear if anything weird happens. Yeah, that's way too loud, so thanks, bro. That squealing noise is new. I mean, at least I'm assuming that's something that's wrong and not just... Yeah, these gears have become really loud, like... Yeah. But like, loud is okay because, you know, it's not supposed to be quiet. But it didn't seem like it was that loud before, so I wonder what the change is. Well, I'm gonna just take it apart again and see if anything obvious has changed in here. All right, I'm getting more wheel debris in here. So I'm thinking what's happened is this is more wobbly. Probably the hub is starting to fail. We'll see. So this hub has failed spectacularly. Guess that's just what happens. So I had tried putting extra grease on in case that was it, but obviously now that I take it apart, like this is already rattling within here. This has melted more. It's holding onto the wheel okay. Actually, so this is starting to slide through. That's within acceptable thing. There's extra constraints within the bearings, the needle bearings that go here. So yeah, what I think I'm going to try and do next, I'm going to run this. I'm not going to put the little spacer in there that prevents it from going too far, because I see if I put it here. So if it goes too far this way, it actually just bumps into here, and so it's still okay to slide back, and then it'll be further constrained because it'll be on a shaft. So hopefully nothing bad can happen from it being like this, but we'll see. And then yeah, the wheel should naturally push backwards as it's going because it'll be sent away from the center of rotation, which is around here. So yeah, hopefully that just corrects the issue and we're good to go. And plus I'll get my testing done on the smaller wheel this year. All right, so I've got my smaller wheel on here and it's working okay. Throwing grease all over the place, which is unfortunate, but okay, so I have no bumper to keep the wheel out. The centrifugal force should do that for it, but we'll see what happens when I try to spin it up. So on first glance, the small wheel works better. Started getting a little noisy again, just like the other one did, but let's take a peek. Let's give it another start. It seems to start up and run a little. Some parts are a little less controlled. Let's see. Yeah, so it definitely has a harder time getting up and going, and I'm guessing this part might be because there's no spacer keeping the wheel, that initial bit going. I could throw a thrust washer in there with a spacer, and that should hopefully balance this out. I don't think I have time to do that today anymore. So next time I'll try that, see if that makes it just a little bit more stable. The annoying thing is I'm really close to the weight limit, and running out of time to test. So we'll see what we get. And yeah, the other thing is, so the heading was a little off there, and that is, I think, just because this wheel weighs 50 grams left, and I think it's just shifted the center of mass of the robot just a little bit enough that it's making it off. But I do have a backup plan as well of popping heavier bolts in the back here. Heavier bolts in the back here if I need to help shift it back further, or I could just try calibrating it on the fly, just because while I have to flash the controller to calibrate it, I can do math so that I can get it like to 95% quality within a single calibration run. Okay, something I'm noticing as it's sitting here is this has gone all crooked on me here. Yeah, this pinion slipped out, that's all that happened. Okay, so that's not a problem with this design. I need to Loctite the pinion still. I think I got an idea of what's going wrong here and why these keep crashing into it. So my initial thought was simple of when it's spinning around, basically it's outward forces from the center of rotation, right? But what I was failing to consider in my thinking was that in order to move, I pulse it on for half rotation and off for another half rotation. That causes it to throw it in a given direction. But if we are, say, on for one half and off for the other half, then what ends up happening is if it's throwing in a direction that would push the robot this way, that means the wheel has force going this way, and that's what's causing it to push in and either take the bumper that I've had there before or crash the smaller wheel right into the frame here, which caused it to like bind up into these gears. So that means that I don't have a choice. I have to put a second thrust washer here. Fortunately, I ordered a 4-pack when I got the ones for this. So I just need to make sure I can do that with all the weight, and that should solve the problem there. And hopefully I can still run with the big wheel and the small wheel. And yeah, that's that. So an oversight I should have seen from my own experiences on this, but sometimes it's just the way it goes. So this is to explain my hopeful final setup for this. So we have, just a little spacer here, it's PLA. And then we have a thrust washer. Then the wheel is going to go on like that. The thrust washer actually fits inside here. And then we'll have another thrust washer, spacer, and then the support. So these two pieces here support the shaft, and hopefully that keeps one contained unit and that everything lines up okay, but we'll see. It's a lot more sturdy this time. Let's give it a go. That obviously worked pretty well. One thing that seemed a little odd is that at the beginning it was all good, but when I put up the throttle a bit more, it didn't feel like it quite spun up as high. And I'm not sure what the reason is. This has play in it now, and a lot of play. So let's see, am I showing you here? Yeah, this has a lot of play in it now. So I think something is melted in here, and hopefully whatever it is, I can get a replacement piece out of there made of aluminum. Like, I hope it's not the hub. I hope it's the spacer in there, because I can realistically go get something, go get some shims out of just aluminum and place them in there. But we'll see. Well, this was not what I was expecting. The bearing got mangled. So I'm guessing what happened here is you see all the little screws that hang out over the edge. They trashed it. I wonder how I'm going to solve this. It's just that little bit of wiggle up and down. Let's see if anything else has gone wrong. Okay, so let's look at this side here. So yeah, that melted in there. Problem is here. So obviously the bearing was spinning here, and it just heated up enough, melted a bit. That caused all of this to get a little wobbly. This has become a little loose from that as well, which makes sense. It got too hot. I guess we'll have to see what I can come up with. I can print this out of nylon. That should help a little bit. I think I have some nylon left, and hopefully that fixes this, but I don't know. And you know, obviously future might be a time to get this like CNC'd out of aluminum. So I got 20 minutes this morning to think of a solution that I can print before my kids get up. Here's what I'm going with. Here we see here, I'm going to design a bolt pattern to go into the back here. What will happen is I will take a bunch of socket heads. I'm going to have them pop into here. This will allow it to elevate about 2.5 millimeters off. I can then have the thrust washer sit on top of those screws and then have a smaller spacer at the very back. So the test strategy for tonight is going to be new stack up. We're going to have a spacer right here. Then we'll have a thrust washer. So this piece will go next, and then it will fit into here. And the difference this time is I have these 4 bolts in here that the washer will rest on that will keep it from rubbing against the plastic. Now technically it'll still rub on the metal will get hot. As long as it doesn't pass the heat through, then we're good. So it should be a better handling of the friction, and that's the hope there. And then the rest of the stack up will remain the same. And yeah, I feel like this has got about a 75% chance of working. You know, it's not impossible it fails, but I think it might succeed, but we'll see. Well, that worked until it suddenly didn't. So yes, it ejected some screws. They look to be M3s. So the ring gear that attaches this is held in place by 9 M3 screws, but 6 of them are not like proper connections in, and I'm betting they're the ones that came off. Ooh, yeah, this broke. Oh yeah, the ring gear came off of the hub completely. So that's going to be something I have to look into. So given how much these were moving around, the motors, they were a tiny bit warm, but not too bad. So I think the motors are actually, this was running more efficiently until it suddenly failed. Yeah, so you can see in here, that hub is completely disconnected from that ring gear. So here's the update. I ended up using 4 M3s as standoffs. So I had them screwed in here, and then I tossed the end of the thrust washer cap on here, boom, stacked it up and ran it. Normally the ring gear's on here as well. All the screws ejected out of the thing while it was driving after a little bit. So looking at it, it looks like the screws tore out. It did look like we've got a little bit of warping here, so like it did get hot maybe and warp this. I can't say for sure if that happened before or after all the screws started falling out though, so I'm not sure if it was things got hot and then the screws fired off, or if the screws fired off and that caused extra rubbing, which caused things to get hot. I have noticed though that the bearing did melt the front of even the Bainbots wheel on this side. So that's something that doesn't happen with the 3-pounder. It has a thrust washer right here and it doesn't actually overheat the Bainbots wheel on that. So I need to figure out what I can do. So obviously this melting is not too bad. It's serviceable if it doesn't get worse than this. But then if it's distorting the hub, I don't know what I can do to prevent it, because I'm a bit stuck here for what I can do to prevent this from getting too crazy. I know ideally that having an aluminum made CNC hub would be great, but we don't have time for that. So what I've done to fix the gear popping off is I added an extra 1.5 mils of material into here so that I could screw this in with just, a bit more thread engagement. So 2 more extra mils of thread engagement on all of these 9 M3s around here. So hopefully that gives me just enough more. I unfortunately made a mistake in the CAD. I edited a parameter that moved it 2 mils, but I moved it, instead of moving the whole thing down 2 mils, I moved the inside here up 1.5 mils, so it's a little thicker in there, and that means that there's a 1.5 mil gap here now. For the sake of alignment and stuff, everything will be the same, but this also means that this is 1.5 mils down now. Now the slight advantage of this, it means that I probably will not melt the printed TPU here. I'm also drying out my nylon because I imagine that this will still eventually succumb to heat warping or something like that, and so I'm drying out the nylon to print for tomorrow night. We'll be giving this a shot. I'm expecting this to fail, but we'll see how well it goes before it fails. And yeah, and if it doesn't fail, then great, I'll print some Super PLA Plus of these, and then when the nylon's good, I'll print some of those as well. I'm making a couple changes to the tuning of this robot. So first of all, I'm going to limit the bot's frequency to 30 hertz, or at least that's when the throttle cap will kick in. It might still be able to go a little faster as long as it can push it over with that. But the idea being that like the bot will max out at 1800 RPM, like, and that's entire robot revolutions, not wheel revolutions. And that means that the tip speed will be between 150, 160 kilometers an hour, which is just under 100 miles an hour. And I've also decided to disable braking by default. So I have a button that can choose to toggle whether or not braking is used to help translate. I have decided to turn that off. With braking on, I can translate faster. With braking off, I don't lose as much speed while translating. So it's a trade-off either way, but in this case, I think I want to preserve speed and move a little bit slower because it doesn't move that slow. So that'll be stacked in with, this new hub. So there's a chance this hub won't fail simply due to the fact that it is running slower than it was when it did fail. But we'll see. Yep. So the hub failed, and unfortunately it failed where the M4 bolts went in, which was the result of the print design. That's a shame. It went for, it looks like about a minute before things started going too bad. At least it's translating very well, which is good. I need to adjust my throttle limit. So what happens is I limit it to 30 hertz, and then I cut the throttle down to like 25-ish%, and it was still accelerating quite a bit at 25% throttle. So that needs to be tuned a little differently. Ideally, what I want to do is have the throttle tuned such that it can just accelerate a little bit more so that it stays outside so it doesn't bobble back and forth below 30 hertz, back above 30 hertz, because then it'll just keep like messing with the timing on the PWM pulses it sends to the FETs. So unfortunately, it started shooting out bolts, and then obviously started eating its own wheel at that point because it's fallen off the hub. So I just need to design a new hub for the next iteration and go from there. All right, so looking at the end result here, no melting at all. This is perfectly clean. Let's see if I can focus on that. Yeah, so that's great. On the other side, a little bit of melting right here, but otherwise pretty clean. But a little bit of melting occurred there, or at least distortion, possibly from heat. But switching to nylon will hopefully actually solve this. Yeah, I think just adjusting the print mistake I made with this, as well as printing this in nylon, might just be the solution that I can get away with. I also want to lower this lip down a little bit, just like it was by accident essentially this time. I was thinking about having it do that anyway, so that even if this does start to melt here, it reduces the chance it rolls over and covers the bearing in here, because then it's hard to extract it to move it to a new hub. So that's the changes for this will be lower. So hopefully tomorrow night, which will be Monday, getting really close here, I'll have a 3D printed hub that will be able to be tested and will work. All right, it is Tuesday at 11:30 at night. I am doing what is hopefully the final hub test. I have changed the hub to a nylon hub. I dried out my nylon as much as I could, but it's not the greatest, so I've compensated in the CAD for that popping it does from the moisture. It's not coming out the greatest, but I think it's close enough. So the hope here is that the lack of heat, or the fact that it can resist heat more, will cause it to not warp and the system to fail. This really needs to work tonight, because tomorrow is building spares for some extra things, like building a couple spare speed controllers and tapping a couple extra spare like support posts, stuff like that. And then Thursday is packing, and leaving is Friday morning. So hopefully this works, because not a lot of time left. All right, so that was about a 2-minute run. Things seemed okay. Let's touch the motors, see how warm they feel. Obviously this is just a simple hanging out kind of run, so not quite as intense. The motors are nice temperature. They're a tad warm, but it's cold in here, so I'd say that's a good amount of warmth for them to be. Now obviously it's not under the most heavy mode here, because it's mostly just cruising. Let's try a more aggressive start and see how that goes. So I feel like I get a little bit of wheel spin on the start up there. It's not the biggest issue, but it's be concerned after like an impact. So like I'll get hit, I'll knock off. But anyways, let's try cranking it again. Okay. You can definitely hear this wheel spin. So. Okay, so the hub looks to have not failed, which is good. This seems like enough of a test to call the hub iteration successful after I pop it apart and see. A test I have not done yet, which will be sort of important, I should still try and do, is a test with the small wheel. Realistically, there's nothing that should be a problem with it. Since the center of gravity is about here and we're actually holding on the end over there, there's still enough weight, I think, on the small wheel that it won't be an issue. And I mean, I've run it a couple times before. I just had other issues with it. Part of me is like, no, I shouldn't do it right tonight because it's already 11:40 at night. So I should just pop this in, do a little inspection, put the batteries back down to storage charge, and call this a win for tonight. Oh, I smell a little bit of electronics in here. Oh yeah, those motors have gotten a bit toasty now. Yeah, they're a bit warm now, but that was doing a lot more heavy starting, so that makes sense. Yeah, they're warm now. Let's just do a little roll to see if they feel okay. Yeah, nothing seems too off here. Uh-oh, that might be an issue. I think something has fallen apart here. I think the spacer at the back has melted, so this might need to become nylon as well. So some stuff has started to fail, so it's still running pretty well even with components failing on it. If the component only lasts 3 minutes, it's fine because it's just, a printed part. I can just replace it every time. Well, let's take it apart and look at it. Anyways, that's enough for now. Isn't it great when you finish testing and your battery is just already at storage charge? It's happened a couple times. It's funny every time it does though. So unfortunately that spacer did need to be replaced and I made it out of aluminum. But fortunately I had an earlier version of the motor mount plate which was exactly the right thickness and that did the job. So the end result came out very nice. My CNC machine is at worst seems to be about 0.2 millimeters off. So yeah, this will work as the spacer that goes here. And now it absolutely, definitely will not melt. So yeah, I got a couple hubs on the way going here, but I'm gonna have to work on them later. I might finish wiring up my spare electronics because a storm is coming, and getting that done before my kid comes home is probably better. Spare electronics complete. So it's Thursday at 1:40 a.m. right now. The bot's basically almost good to go. I've Loctited all of the bolts except for the top stuff. One weird thing has happened, and that is, for some reason, a space has developed here. I don't understand. Everything was tight before, and now it's just suddenly smaller. I don't know what's going on here. This is the hub I had tested on before and everything, just the other day. So I'm not sure what's causing this problem, but this is the new spacer I created. So I still have the old one, which will hopefully take up that little bit of slack because it's, it's a couple mils. And yeah, the more play this has, the more it can rock back and forth, which is going to cause issues. But the thing I just don't get is, where did this play suddenly come from? It doesn't make sense to me. This assembly, yeah, it just seems so weird. But oh well, it is what it is. Yeah, there's a chance it's actually come from melting down the face on this. Be funny if that's the case. So it was at this point something very interesting happened. I had been printing my nylon pulleys like this, or they'd been coming out like this. So you can see the finish is very rough. Yeah, the dimensions weren't coming out quite right. And I had assumed that I couldn't get the filament dry enough, or they'd changed something with it because recently, this is a alloy 910. It had been bought by another company and I thought they may have changed something or whatever. Like I said, I wasn't sure if it was me or something like that. But then a very interesting thing happened, and I accidentally printed it with the wrong settings. So I printed the hub off with my Super PLA Plus settings, and it came out like this. So perfectly beautiful, dimensions were spot on, all that stuff. So what I ended up doing was I quickly whipped together a few more with the new ones, and they turned out quite well and just managed to look like they were going to hold together. And just to highlight how many different hubs I went through during this process of a week or so, here is a bunch of other ones that never ended up even being used in the final product. They were just steps along the way, that either they were like copies, but then the first one failed testing in such a way that I knew the other ones were going to fail or whatever. It was just quite the iterative process to get through to the final design, which ended up being used in the robot in the end. And as a note then, I guess, for anyone who's using Alloy 910, apparently you can print it at only 230 degrees Celsius, and it works, which is below what they would even state is acceptable heat. So yeah, sometimes things just work out at the last moment. So it's good enough to go. It's amazing that issues keep cropping up. So yeah, I put the thicker spacer in there for now. There we go. Within weight, it has 43 grams to spare. Look at that. I had to put shorter screws in there. I wanted to have basically the bolts run all the way through halfway in for all 6 of the points that the weapon's attached to, but I just don't have the weight for it. So I got 20 mil screws here, here, and then there, and then 35 mils there and there, and then of course the same on the other side. So these two are enforced basically the whole way through. And then these ones aren't as much. There's just no weight left for it. I could maybe try and swap these front two now that I see what the weight it's currently at with its final weighing. But I've just tested and yeah, everything's working. The battery's just like haphazardly in here right now. But everything is wired up, it's working. I haven't run its absolute final test, but I'm not going to. Like the tests I've run so far imply it'll be fine to just take it straight there to Moto and do it. But basically I can't test with the weapon on anyways. This thing is definitely too dangerous for the size of test box I have. But yes, I've had no electrical glitches. That's good. I've slowed down the starting torque on this wheel to only be a little under a fifth of the throttle, just because this is giving wheel spin otherwise. The small wheel is even worse for wheel spin, which is unfortunate because that removes options for me. But yeah, everything's working nicely. I did end up killing a battery, which was strange. One of my tiny ones like this. So these things are hooked up in series. And one battery wasn't losing any current and the other one died. I don't get why that would have occurred. I'm guessing some internal resistance failure or something like that. So don't know why that occurred, but anyway, that's neither here nor there. The important thing is that everything is together. It looks like it's working. It should be able to compete and well enough that we'll find out what the new points of failure are. I suspect this hub wheel assembly is still going to be not perfect, that there'll be some kind of failures in here. Either something will start to melt and warp unexpectedly or whatever. There's a chance that these motors will start to overheat too, that just pushing it too hard if there's a lot of impacts, but we'll see how that goes. Realistically, the gearing can be improved a little bit if I just, got smaller gears here and then move these motors accordingly. But, that's to learn for next time. I think the electronics will hold out mostly okay. I hope the fans aren't an issue. They've been in other times, but hopefully it's just not overloading enough that it is an issue. But if it is, I bought specifically a tool that will allow me to open up the cans and specifically just narrow enough on the grasp there to pull the tabs off of these cans, and I will have off the cans of these motors. So like the tabs, yeah, that you can see them there. Anyways, so that I can easily pull the fans out of a different set of motors if I do burn these ones out. Changing the motors might be annoying because I'll have to desolder them and it's a little tight in here, but taking this whole assembly out is, this needs to come out anyway if I need to change the motor. So it'll be the case of I'll have to at least take all of this out to change the motor, so that includes the battery packs. I could technically leave them in if I was extra fussy, but it's easier to take the battery packs out with it. And sometimes it might even be easier to take the actual entire electronics assembly as well. It would be 12 extra screws. I'd probably actually take the lights off the top as well. So 14 extra M3 screws. So a little annoying, but if the motors are blown, that might actually be the fastest way to be able to just access everything, get things apart, and reach all these tight spaces quickly. So concerns for what it is. I actually hope my first match is against whatever the huge like is for the 12-pound league. I don't remember its name. Because I think that would be the best match to both be challenged and also have a good chance of winning. What I really don't want to fight is any kind of hammer saw kind of robot. I mean, in theory, an overhead saw bot would actually be even worse for me to fight, but that's even less likely to occur. The reason being that I have 1/4 inch here, and I think it's about 1/4 inch here. I can't remember what it is. Maybe it's 6 mils or something. It's whatever made the rest of the gap, so that this was centered for the remainder here. And I expect a hammer saw to go through 1/2 inch, so it would be really tight if it hit right in the battery spot. I don't care if it hits me and writes off or destroys a component. It's mostly if it hits a battery and causes a fire that I'm afraid of. And I don't know if this TPU slash UHMW armor would be enough to slow the blade down before it could puncture the battery. But we'll see. I really like how neat it all looks. The wiring looks a little messy right now because I've just thrown the batteries in haphazardly, but how clean everything came out in this and how symmetrical and everything it is. It's really pretty nice looking. So yeah, it's there. Should hopefully work. And we'll see if it's exciting or not. So we've made it to Motorama, and now it's time to safety the robot with the weapon tooth on for the first time.
Oh, wow.
I also use safetying to grab some calibration data to better tune it with the weapon tooth on. I also do a max throttle from standstill test to make sure that my throttle limiting works as I expect it to.
Okay, good.
And yep, it does.
Let's just finish that.
I do the first calibration computation in Flashbound to Witness Me, and this is just us checking to see how well it went. And it really brings up something I should have thought of sooner. If you're going to run your robot at about 30 Hz, maybe don't record it at 30 Hz. It's why it looks so glitchy sometimes on the film, because it's just lining up perfectly, but it means also that sometimes the heading light doesn't show up very well. So this will require another round of calibration. I believe afterwards it was close enough that, given that I was running 2 robots at this event, that I just decided to go with it. My first opponent is Nightcrawler. Outside of it being a good-looking beater bot, it actually has one of the coolest drive systems I've ever seen. The motor is integrated into the axle, the gearbox and speed controller are integrated into the frame, and the wheel clips nicely on top, making for wonderful packaging. My plan for this fight is to just try and get some good engagements and see how the robot handles it. My tuning isn't quite spot on yet, so I know it won't handle as well as my 3-pounder does, so I'm just going to go at it and hope for the best.
3, 2, 1. And Melty's getting up to speed. He's going to rely on that metal bar in the center to hold up. It's the ablative player. Still holding together. Nightcrawler taking its time, lining up those hits. Witness Me kind of right at the top for a second. Nightcrawler almost a little unbalanced there for a second. Home run shot. And it still works. Witness Me back up to speed again after getting careened across the arena. Some chunks out of our floor taken as it gets upended. Whoa, so alright. Stop, there's the tap out before we get to that part. Witness.
That fight went about as well as I'd realistically hoped it would. Even though I lost, I was still pretty pleased with this fight. Some notable highlights from the fight is that I take a chunk out of the arena right here. I believe that impact is also the one that breaks a tooth off his beater bar. Our weapon-to-weapon impact that caused Witness Me to fly across the arena and not start for a little bit was because there was a safety check in place. I hadn't put the robot in full combat mode, and so the microcontroller had rebooted and was waiting for me to throttle down before starting up again, so I overrode it and continued on. The huge impact has a couple other notes about it. One is that the impact is so hard it looks like it takes a chunk out of the floor, I'm guessing from the beater bar colliding into it. And the other is that the impact on him is so hard that it actually damages one of his side of drives, even though there was no direct hit on it. And with the magic smoke coming out of the bot, it's time to go open it up and see what went wrong.
Alright, so for the damage report, we've lost all of the heading lights except for one on the bottom, right? No, all of them are gone. The blue lights, the bottom lights, I think actually still work. Yeah. So we got obviously a direct can hit. Our drive system is locked up. I can't do that at the same time. Yeah, drive system's completely locked up, which is what something calls the smoke at the end there. It's probably one of the motors burnt out. The shell is in excellent condition at least. And yeah, so it's just the motors that need to be replaced, and the heading lights.
It's a good match. Like every time you got hit, like at least you moved like straight up.
Yeah.
Like a frisbee.
All right, so internal damage here. The switches popped off of their hosts. All the LEDs broke. This wire came undone from this motor here. Yeah, and we lost a MOSFET on one of the speed controllers. So yeah, time to repair. We attempted to fix this board. The MOSFET had desoldered. I tried resoldering it back on. When we ran it, the motor sparked like crazy. I don't know if the motor was to blame or the speed controller, but we just cut both out and are starting fresh. All right, so the wheel damage from this event, or fight with Nightcrawler. So he obviously nicked it here, peeled up some of the rubber. He also hit it here, peeled up some of the rubber, and also we got a lovely crack that runs through this wheel right here.
The motor's locked up because one of the fans melted, seizing the whole system up. Another fan melted too in the process. We managed to pull it out, but it took a very long time. Due to feature creep while designing the drive pods in Witness Me, it was way too time consuming to get things put back together, and we ended up missing our next fight, so we're preparing for a grudge match. There was a hope to pull out the motor fans for the grudge match, but it was just too time consuming, so we gave up on it. And with all that, our opponent is F3. This robot is a bit of a novel approach. Instead of putting all of its effort into one strong blade, it spread them across 3 less durable blades. Witness Me's tooth sticks out the front of the robot further than the blades off of F3, but since it doesn't rotate around the center of its circle, the chance that F3 can actually nick the back of Witness Me is pretty high. So with that, let's see how it goes.
3 minutes on the clock for this grudge match. If this goes a distance, we're going to rely on our crowd vote, and who wins the fight, so hope you guys are paying attention out there. Well, there's one this down. Hey, there's 2 to go. That weapon got bent on the disc. And Melty Brain is moving to see how it's just way forward and backwards. That is the uniqueness of the Melty Brain spinner. Oh, that breeze is coming good. Oh, that sounded expensive. F3 is down to 1 working piston. And 1 wheel of drive. And then we come from F3 to F1. Oh. Reverse the GSL and we're toasting the Melty Brain here. Oh, we got hope. Okay. It's not that spooky yet, but I think we're done. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Well, that end result was unfortunate. I have to say, given the banged up condition of the floor, Witness Me still traversed pretty well in it. I did manage to get hit in the back once, I believe at this point here. But the most unfortunate part was when the robotics caught fire there. So at that exact moment, I was trying to spin down Witness Me a little bit to make it run a little slower, just to try and conserve heat a bit. And it was exactly, I was looking down, messing with the throttle when that spark of fire went off, and I was told it looked better in person than it did even on video. And then with one motor down, the other motors quickly became overwhelmed and it just fell apart from there. I realized after that last hit that I probably could have just spun down and let them count him out for being immobile. But not only would that have been less fun, but there would have been less to learn from that, so I decided to keep going. So, for the damage report on their end. My first strike managed to damage their carbon fiber as well as their weapon stack assembly. Their second weapon stack assembly looked to come out much better. I think what actually happened is I'd hit the top bolt on their setup, which would explain why the bolt was sheared, but the rest of the assembly still looks pretty good. They also had one of their gearbox mounts split along the layer lines. Now as for me...
Alright, so let's go over the damage. Internally we have a ruined MOSFET here, but just one of the 4. The lights popped out here, they did not pop out here, that's nice. At the back he hit us once, right there. Boom. I think that's it, and then obviously the motor damage we'll see. We got melted fans, the other one's melted on the other side too, and that's probably all of it. It looks a little black in here, maybe those are toasted now, we'll have to see it another quick. If we get the flashlight angle there, yeah, there's burnt coils in here. So, yeah, so that motor obviously went. I mean, probably, it's quite possible all of them went at this point. Is this the speed controller for the, yeah, this is the MOSFET at least for this one. So, the most burnt motor is also the one that had the speed controller fail. I am very happy with the speed controller failure state of ejecting itself from the robot. It's a lot safer than taking the whole, or locking the robot on. So yeah.
In both fights, the weapon tooth is hitting so hard that it's bending all 6 of the aluminum standoffs used to retain the weapon. It doesn't show up too well in the video here because the bolts are partially keeping it in line, but when I go to take the front apart, they're actually so binded up that I need to hammer them out. And with that ends Witness Me's journey to Motorama 2025. So, as for what's next for Witness Me, the LEDs are going to be swapped to SMD mounted LEDs. This will stop them from being punched all the way through here. The gearing will be modified right now. I hope to, this is about 3-to-1 right here, and I'm hoping to change it to 6-to-1 so that I can get just that much less stress on the motors, at least hopefully. I might have to pull out this rear armor here, like basically remove it entirely. Everything else is contained enough that it won't actually reveal anything other than like, removing the safety that actually mattered right there. But the idea would be to do that so I can change these posts out. Currently these are aluminum. Obviously wasn't strong enough. Even though I ran bolts that ran basically the whole way through, still wasn't enough. What I could either do is I could run like literally a solid stud all the way through these, but I'm thinking more I'll just replace these with steel instead of aluminum. But the unfortunate thing would be that replacing these with steel and also removing this to make weight for that will cause the center of mass to shift more forward this way. That'll end up removing my bite, not because this distance will change, but because its rotation will be further here, which means that basically the butt sticks out more as it's spinning around. So I don't know what I'll be able to do if I'll have weight to mitigate that backwards. And I also plan to pull out the fans for the next iteration so that they just can't melt and lock up the system. I also plan to modify, can I even see in there? Yeah. These posts basically to have nuts embedded in there so these threads stop pulling through the TPU there. I also plan to make it such that these motors will be easier to swap in and out. So the idea is that hopefully I can more quickly remove this entire segment. There was a slight issue where in order to support these motors, that makes, a simple clip here, like a simple connector, not as easy to do. But what I figured I could do is I could run a connector here, and then when it comes swapping them out, you unplug the 4 motors, take the whole unit out, and then just desolder on one side, and maybe I can feed the connector through on the other side if there's enough space there. There might not be though, but either way, it's easier just to work on, to be able to take the full unit out and swap them that way. It'll take a lot less time than having to like work with these wires actually connected to something, because that room restriction costs a lot of repair time. Ideally, I'd make more drastic changes than that to help sort this out. But, time and money are 2 things that I have to budget for. But we'll do the best we can. Thanks for watching.